how specific tax effects depend on elasticities. We now turn to our second question. Who is hurt by the tax? To answer this question, this comparative static question, we want to determine how the price that consumers pay and firms receive changes after the tax is imposed. Because the government collects a specific or unit tax, TAU, from sellers, sellers receive P minus TAU when consumers pay P. We can use this information to determine the effect of the tax on the equilibrium. In the new equilibrium, the price that consumers pay is determined by the equality between the demand function and the after-tax supply function. Capital D of P equals capital S of P minus tau. Thus, the equilibrium price is an implicit function of the specific tax. P equals P of tau. Consequently, the equilibrium condition is capital D of P of tau equals capital S of P of tau minus tau, equation 2.26. We determine the effect a small tax has on the price by differentiating equation 2.26 with respect to tau. D capital D of over dP multiplied by dP over d tau equals the derivative of supply with respect to price multiplied by the derivative of P of tau minus tau with respect to tau equals the derivative of the supply curve with respect to price or multiplied by the derivative of price with respect to tau minus 1. Rearranging the terms, it follows that the change in the price that consumers pay with respect to the change in the tax is the derivative of price with respect to tau equals the derivative of supply with respect to price over the derivative of supply with respect to price minus the derivative of demand with respect to price, equation 2.27. We know that the derivative of the demand function with respect to price is less than 0 from the law of demand. If the supply curve slopes upward so that the derivative of the supply curve with respect to price is positive, then the derivative of price with respect to tau is greater than 0, as figure 2.12 illustrates. The higher the tax, the greater the price consumers pay. If the derivative of supply with respect to price is less than 0, the direction of change is ambiguous. It depends on the relative slopes of the supply and demand curves, the denominator. By multiplying both the numerator and denominator of the right-hand side of equation 2.27 by P of capital Q, we can express this derivative in terms of elasticities. The derivative of price with respect to tau equals the derivative of supply with respect to price multiplied by price over quantity, and that is over the derivative of supply with respect to price multiplied by price over quantity minus the derivative of demand with respect to price multiplied by price times price over quantity, which equals nu over nu minus epsilon, equation 2.28, where the last equality follows because the derivative of supply with respect to price and the derivative with respect to the derivative of demand with respect to price are the changes in the quantity supplied and demanded as price changes, and the consumer and producer prices are identical when tau equals 0, superscript 20, which reads, to determine the effect on quantity, we can combine the price result from equation 2.28 with information from either the demand or the supply function. Differentiating the demand function with respect to tau, we know that the derivative of demand with respect to price multiplied by the derivative of price with respect to tau is equal to the derivative of demand with respect to price multiplied by nu over nu minus epsilon, which is negative if the supply curve is upward sloping so that nu is greater than 0. This expression holds for any size change in tau if both the demand and supply curves are linear. For most other shaped curves, the expression holds only for small changes. We can now answer our second question. Who is hurt by the tax? The incidence of a tax on consumers is the share of the tax that falls on consumers. The incidence of the tax that falls on consumers is the derivative of price with respect to tau. The amount by which the price to consumers rises is a fraction of the amount the tax increases. Firms receive price minus tau, so the change in the price that firms receive as the tax changes is the derivative of price minus tau with respect to tau, which equals the derivative of price with respect to tau minus 1. The incidence of the tax on firms is the amount by which the price paid to firms falls, 1 minus the derivative of p with respect to tau. The sum of the incidence of the tax to consumers and firms is the derivative of price with respect to tau, plus 1, minus the derivative of price with respect to tau equals 1. That is the increase in the price consumers pay plus the drop in the price paid to firms equals the tax. In the pork example, epsilon minus epsilon equals negative 0.3 and nu equals 0.6. So the incidence of a specific tax on consumers is the derivative of price with respect to tau equals nu over nu minus epsilon, which equals 0.6 over open brackets 0.6 minus open parentheses negative 0.3 close parentheses close bracket equals 0.6 divided by or 0.6 over 0.9 equals 2/3. And the incidence of the tax on firms is 1 minus 2 over 3, which equals 1/3. Thus, a discrete change in the tax of delta tau equals tau minus 0 equals $1.05 causes the price that consumers pay to rise by delta P equals P sub 2 minus P sub 1 equals $4 minus $3.30 equals open bracket nu over nu minus epsilon close bracket delta T equals 2/3 times $1.05 equals 70 cents, and the price to firms to fall by 1/3 multiplied by $1.05 equals 35 cents, as figure 2.12 shows. The sum of the increase to consumers plus the loss to firms is 70 cents plus 35 cents equals $1.05, which equals tau. Equation 2.28 shows that for a given supply elasticity, the more elastic the demand, the less the equilibrium price rises when a tax is imposed. Similarly, for a given demand elasticity, the smaller the supply elasticity, the smaller the increase in the equilibrium price that consumers pay when a tax is imposed. In the pork example, if the supply elasticity were nu equals 0, a perfectly inelastic vertical supply curve, the derivative of price with respect to tau is equal to 0 over open bracket 0 minus open parentheses negative 0.3 close parentheses close bracket equals 0, so that none of the incidence of the tax falls on consumers, and the entire incidence of the tax falls on firms. Equation superscript 21, which reads, for another application, see incident of a tax on restaurant meals in the supplemental material to Chapter 2 in my Econ Labs textbook resources. Solved problem 2.4. If a product's demand curve is perfectly inelastic and its supply curve is linear, sloping upward, what effect does a $1 specific tax collected from producers have on the product's equilibrium price and quantity? What effect does the tax have on consumers, and why? Answer: determine the equilibrium in the absence of a tax. Before the tax, the supply curve, capital S superscript 1 in the figure, intersects the perfectly inelastic vertical demand curve, capital D, at epsilon sub 1, where the price is P sub 1 and the quantity is capital Q. 2. Show how the tax shifts the supply curve and determine the new equilibrium. A specific tax of $1 shifts the pre-tax supply curve, capital S superscript 1, upward by $1 to capital S superscript 2. The intersection of capital D and capital S superscript 2 determines the after-tax equilibrium, E superscript 2, where the price consumers pay is P sub 2 equals P sub 1 plus 1, and quantity is capital Q. 3. Compare the before and after tax equilibria. The specific tax does not affect the equilibrium quantity, which remains at capital Q. The price rises by $1 from capital P restarting the sentence. The price rises by $1 from P sub 1 to P sub 2 equals P sub 1 plus 1. Thus, the entire incidence of the tax falls on consumers. delta P over delta tau equals P sub 2 minus P sub 1 over $1 equals $1 over $1 equals 1. We get the same incidence by setting the demand elasticity equal to 0 because the demand curve is perfectly inelastic. In equation 2.28, the derivative of price with respect to tau is equals nu over nu minus epsilon equals nu over nu minus 0 equals nu over nu, which equals to 1. 4. Explain why. Because the demand curve is perfectly inelastic or vertical, consumers continue to buy the same quantity even if the after-tax price rises. For suppliers to continue to provide the same quantity as before the tax, the price they receive must rise by the full amount of the tax. Effectively, the reason why consumers must absorb the entire tax is that consumers will pay anything for this good. Application: gas taxes and the environment. Burning fossil fuels such as gasoline, coal, and heating oil releases greenhouse gases containing carbon into the atmosphere, which contributes to global warming and other associated climate changes. To reduce this problem, many environmentalists and political leaders proposed levying a carbon tax on the carbon content in fossil fuels because 1/3 of U.S. carbon dioxide emissions come from the transportation sector. Knowing how buyers will respond to the tax is crucial to determining how effective the tax will be. Davis and Killian, 2010, estimate that in the short run, up to 1 year, the price elasticity of demand for fossil fuels is negative 0.46, which is inelastic. All else the same, the less elastic a demand curve is, the smaller the effect a tax will have on equilibrium quantity. As solved, problem 2.4 shows. For a completely inelastic demand curve, the tax has no effect on the equilibrium quantity, and consumers absorb the full price instead. A commonly proposed tax of $10 per ton of carbon dioxide would increase gasoline taxes by about 9 cents, roughly half of the current federal specific gas tax of 18.4 cents per gallon. Bento et al., 2009, estimate that a 25-cent gasoline tax would increase the average household's cost by about $30 a year in 2001 dollars. Given their elasticity estimate, Davis and Killian calculate that adding a 10-cent gas tax would reduce gasoline consumption and carbon emissions from vehicles in the United States by only about 1.4%, thereby reducing U.S. carbon emissions by 0.5% and worldwide carbon emissions by just 0.1%, because total U.S. carbon dioxide emissions increased by 1.1% annually between 1990 and 2007. The tax would roughly offset half a year of growth in total U.S. emissions. Such a tax would not have a substantial effect on carbon emissions in the short run. Unfortunately, Bento et al. 2009 do not find that a tax on gasoline consumption will have a much larger effect in the long run.